Can you hear me? Am I audible or not, Aditi?
Yes, sir.
Okay. Okay. So EA costs 5 here. So if it is like non like not constant volume or not constant surface. Okay. So if suppose electric field is not constant throughout the surface, irregular surface that. So for that, what we'll do? D phi equals to E dA. We'll integrate here. We'll integrate throughout the surface here about this surface. So in short, what we can conclude from here, electric flux is what? Product of E and A. And product of two vectors gives you scalar. So if I want to get some integration value here, so there should be some limit here. So limit varies from minus to plus. We'll just vary it like somehow, somewhere. From minus to positive, negative to positive. Or for that, we will get negative EA to minus. So it varies from minus EA to plus EA. Minus EA to plus EA. Gauss law. Am I audible clearly, right?
Yes, sir.
Okay. Now, Gauss law, he was a guy, he just gave a law about this same thing actually. But he gave some different way. That is, he says that like if it is a closed surface, suppose if this is the closed surface. So we named this surface as a Gaussian surface. Closed and closed surface. So Gauss law states that there is a closed surface in vacuum which is equal to 1 by epsilon naught times net charge. So this is your closed surface. So if we take a small surface or a small area for that, small dA, so phi equals to line integral E dA is proportional to or equals to Q in by epsilon naught. Q in means total charge inside. Q in means total charge inside a surface. So this surface is called as Gaussian surface. This closed and enclosed surface, Gaussian surface. Okay. Any question here? Shall I take next thing?
Yes, sir.
Okay. In this one, some points to remember, like net electric flux. Net means total electric flux through this surface, or let's say any closed surface. Depends only on charge inside that surface. So if I take some surface here, like so if I take here something Q1, surface S, Q2, Q3, surface something S dash, surface S triple dash or double dash. So in first case, net flux will be Q1 by epsilon naught. For the second case, will be Q1 plus Q2 by epsilon naught. Then what will be for third case?
Q1 plus Q2 plus Q3 by epsilon naught.
No, cannot be like that. This is the first case, second case, third case. For will be zero because there is no net charge. What we wrote here, net charge into 1 by epsilon naught times. So there is no
Okay.
net charge. It will become zero.
Okay, sir.
Next point to remember, if like let me draw and show you. Oh no, something like that. If it is outside, means if point charge Q is outside a closed surface S. Outside here, point charge is here. So then this will be, these are the electric field lines. This all are electric field. Is so number of field lines which is entering, and you can see this number of field lines entering the surface will be equals to number of field lines exiting. Number of entering equals to number of lines leaving. So what we can conclude here, net flux will be 0. A closed surface. But why? Because it is same case. Okay. Because, or if there is no charge, if there is no charge inside, should both points. Depends only on first point, or depends only on charge inside the surface. So if there is one charge, it will be Q1 by epsilon naught. If there is two charge, Q2 by Q2 plus Q3 by epsilon naught. If it is no charge, it will be 0. Second case, whatever electric field is this entering, field lines entering, it will be same as exiting. Therefore, there is no net flux. If there is no net flux, that means what it says, no charge inside. Clear? Any question here, girls?
No, sir.
No,
Okay.
sir.
Now let's write just last point for this, then we can go for something problems here. We'll go for problems. So net flux, this is conclusion. Net flux across surface, suppose this is the surface, minus Q plus Q. Surface, let's name it A, is 0. That means what? Phi equals to E ds equals to Q in by epsilon naught equals to 0. Q in means what? Plus Q minus Q. So obviously sum is 0. Net is 0 here. Plus Q minus Q. So in this case also it will be 0. So we got some cases that has 0. When there is no charges, when electric field lines entering and exiting is the same. And when there are charges are opposite, equal and opposite. Let's see here application. Now application is what? Just for finding electric field. What will be effect of electric field at a point? Or electric field due to point charge. Where is this circle? Yeah, let's draw a circle here. This is our Gaussian surface. Charge at distance r, at distance r, and if I take small areas, there will be electric field E and area dA. So for that, phi equals to EdA, which is equals to Q by epsilon naught. So E equals to Q 4 pi epsilon naught r square. If it is a sphere, 4 pi r square. Area will be 4 pi r square. A equals to 4 pi r square. Second application we can say for a cylindrical. This is for point charge at some sphere or symmetric charge distribution. This will be a length. Okay, so for finding area for this one, we need to check for both things like the surface as well as cylindrical surface and both ends. So actually flux across, if I take electric field lines on this direction. Okay, on this surface it is 90 degree. So cos 90 will be, see, electric field and area. Electric field is here, area is this one, dA. And here if I take some, consider this one, so electric field is in this direction, area also in this direction. So cos 90 will be 0. So first condition, if I take both ends, so phi EdA, if I take here flux for ends plus flux for cylindrical surface. So it will be 0 plus surface. The whole surface here, like a 2A, we can say, into E. So area of this one will be pi r into L. So 2E equals into pi r L equals to Q by epsilon naught. And this is lengthwise, we are taking here whole this, suppose this is your charge plus 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 plus. This is your lengthwise, so charge per unit length. Lambda equals to charge per unit length. So Q equals to lambda L. So we can substitute here. E equals to lambda L 2 pi R L epsilon naught. So you will get lambda 2 pi R epsilon naught. Clear?
Yes, sir.
Okay, so I want to take some questions here. It is an infinitely long, thin, straight wire charge density 1/3 centimeter inverse. Find magnitude of electric intensity at 0.18 centimeter away. Similar type, cylindrical wala. So lambda is given here 1/3. Just now we wrote formula, same formula. E equals to lambda by 2 pi r epsilon naught. We know that 1/4 pi epsilon naught is 9 into 10 to the power 9. So what we can do? Multiply and divide by 2. So lambda is 1/3 into 2 into 9 into 10 to the power 9 divided by r. R is what? 18 into 10 to the power minus 2. That's it. Over. 1/3 means 0.22, 0.2, sorry, 33. 10, no, sorry, 9, 10, 11. So into 10 to the power plus 11 Newton per Coulomb. That's it. Simple.
Yes, sir.
Okay. Done. Application, Gauss law, everything. Any question in Gauss law application? So Sunday, maybe tomorrow, I don't know, we have class or not. Tomorrow, what subject? Let me check timetable. But okay, but Sunday if we have,
So like there's no
so
even exam also even on Sunday.
I'm willing to keep this topic. Are you okay with this? Ready? Are you ready for this chapter? Shall I keep test?
So like only you or all the three subjects combined?
No, like there will be three tests. Three tests. Physics, chemistry, bio. Sorry, not bio, mathematics.
Oh, separate.
Yeah. On the same app, like multiple choice questions will be there. Okay, this time I'll just give you first theory type. Then once we start solving this tomorrow, day after tomorrow, whatever it is, we'll solve this like JEE questions. Okay.
Okay, sir.
So shall I keep test?
So like theory based?
Yeah.
Okay, sir.
Okay then. I'll just give 10 questions. Okay. And timing will be just 2 minutes for each question. Not more than that.
Okay, sir.
Okay, sir.
Okay, guys. Bye bye.
Thank you, sir.